Hello, and welcome to this week's episode of AWS Shiba's Tech Skills. Thank you so much for joining in. You might have seen me in the previous episodes. My name is Jigna Gandhi. I'm a senior solution architect with AWS, and I support our customers in the cloud journey. And I'm so excited that I'm going to be your host for today's show. We also have Brittany Wolfram with us joining as a moderator, and she's going to be in the background. So feel free to post your comments, questions in the chat, and we'll be happy to answer those as we go along. Just to set the context of today's show, because this is going to be really exciting. In the last few weeks, we have been, diving deep into AI and AI assistance with Q and agentic AI with Strand agents and so much more. So for today's show, we decided, let's take a step further into this and let's dive deep into the topic of Agent Core and how developers can, use it to coordinate specialized agents and, coordinate together into like a seamless intelligence system. So that's the topic for today. And to do all this, I'm excited to welcome Piyali Kamra one more time on our show. Piyali, for our new viewers, can we have a quick introduction and tell us a little bit about yourself?
Well, thanks, Jigna. Thanks for inviting me again to this show. And I remember the last time was a lot of fun. And we'll have a lot of fun today as well. So, Piyali Kamra, I'm a senior enterprise architect at AWS, and I work with a lot of customers in the financial services in their journey, in their cloud journey. So, today we are going to be talking about AgentCore. A little bit about me. I've been with AWS for about 5 years now, but before that, I've spent 2 decades in the tech industry. So excited to be here about and talking about AgentCore today.
Awesome. Thank you so much. And to our audience, just let us know if where are you joining from. We would love to see like the global audience that we have today. Awesome. So I know like like agentic AI is a hot topic right now. And like we have been watching AI evolve from like simple co-pilots that just assist and maybe to the far end where agents can now plan, decide and execute so many tasks of its own, right? So I know we have been seeing in the news like multi-agent collaboration is emerging. Each agent will have like a specified role and they are so deeply integrated with each other so that the entire as an end product you see everything is automated, right? Purely like what trends you have seen across the organizations?
You actually hit upon a lot of them, right? So it's the journey started with simple agents. I call them as assistants. They assist you, make your job a little more simpler. Then you go towards from assistants to like agents, which are collaborative. They collaborate with you to get bigger things done. Then you see semi-autonomous agents, which is what you were alluding to. They start planning, thinking, executing, and then at the other far end of the spectrum is autonomous agents. They can pretty much um, complete entire life cycles on their own. So, yeah, those are the four trends that I'm seeing: semi autonomous, autonomous agents, assistants, and collaborative agents. And we'll see today how these agents can be deployed in an agent core environment.
Awesome, that's great. And we have such great audience. We have Somin from London joining, Brittany from DC. That's exciting. Awesome. Thank you so much for joining us. So before we, start into like diving little deeper, a quick question for our audience, like what AI trends you are seeing? Because I know we both just talked about, but are there any specific ones that you are seeing in your company? We would love to hear them out. As we go along, Piyali, why don't we start with just like some concepts, maybe like, what Agent Core is, or maybe just give us some high level overview so that we can, easily follow along.
Yeah, sure. So we talked about a little bit about semi-autonomous, autonomous agents or specialized agents. You also talked a little bit about multi-agent collaboration. So what happens is as we are building these agentic AI systems, much like how we ventured into the journey from monolithic to microservices, you start realizing that a big agent cannot do everything. In order to do be focused, in order to make sure that your agents are really specialized, you start actually splitting up very organically. You will see that you will be splitting up your single agent into multiple specialized agents, which are very domain specific, or they are focused on a specific work. And we'll see an example of that today in an app that we'll be building. We'll be actually building a document analysis app for financial services or financial documents necessarily. And we'll see how we are using multiple agents over there to basically think and plan, and then transfer the control from one agent to another. And then how the work that is done by a specialized agent, how that is stored into the context, and how that is passed along from one specialized agent to another, so then that another specialized agent has context and can do the next set of work that it's supposed to do. So organically think of it like as microservices.
Nice, that's interesting. I know with microservices there are so many other concepts that come, dependencies and setting the
Exactly.
context and integration and all that. Like how would you address that as this agent core?
And that's where Agent Core comes in and makes our life so easy. So yes, that's a very good segue into what is Agent Core, a very organic segue into why do we need Agent Core. Think about this, just like you have small agents, which are specialized agents. And in a production environment, you will often see you won't just run a single agent, right? You will actually run multiple domain focused agents. For example, in the app that we'll be building today, we'll have a comparative analysis agent, we'll have a deep insight analytics agent, a diagramming agent, then an agent which gives you an executive summary of your document. So think about this, in a production environment, you would be having so many small specialized agents, and these agents need to communicate with each other. When they communicate with each other, they have to share context and memory. So Agent Core is this infrastructure platform in which you can actually deploy your agentic AI systems at scale, and it gives you insights into one thing is memory, storing the context. So Agent Core actually has a feature, a memory feature. So you can actually store long term as well as short term memory. That's one part of it, which we'll cover today. The second thing about Agent Core is the Agent Core runtime, right? So all these agents, if you want to scale them to thousands of agents in production, real time, then Agent Core runtime is actually that environment in which you can deploy your agents. We'll specifically be looking at custom agents. For example, many a times people are like, oh, I have built an agent using LangGraph or LangChain or strands. How do I use these agents? How do I deploy these agents in the Agent Core runtime so that I can scale them to thousands of agents in production? So we'll specifically be going about deploying custom agents today, like multi-agent collaboration, but customized agents in the Agent Core runtime. So that's one part of Agent Core, that is the Agent Core runtime. And the third thing that we'll be looking at today is the observability piece, right? So think about it, as you said, you have microservices, they communicate with each other, they share context with each other, and oftentimes you need to know what's going on. Maybe one agent is not really performing that well in production and it's doing a bunch of tasks, and you want to introspect. You want to see what's going on, where am I losing time. That's where observability piece comes in. So we are going to look at Agent Core Observability. That's the third piece of Agent Core, which is really important when you're dealing with multi-agent collaboration. And the fourth fun thing that we'll be looking at today is the code interpreter tool. So, what I mean is, in our use case today, we have two financial documents that we want to compare. And once we compare, we want to actually graph the growth trajectory over the last 1 year or so. We want to do some comparative analysis, and we all know picture is worth 1,000 words. So that's why we are actually going to be using the code interpreter tool in Agent Core to give it inputs like, this is how my two comparative charts look like. Go ahead, build me a graph, and we'll generate a nice PNG graph in our S3 buckets through the code interpreter tool. And yeah, that's so there are four things of Agent Core that we'll be touching on today. There are many other things, but for today's session, we'll be touching these four aspects of Agent Core.
Awesome. And are you going to show us a live demo? Because everyone is excited to see
Yes,
it live, right?
absolutely, absolutely.
Awesome. Okay. Um, One quick question, like what kind of agents would you normally build for, some of the common use case? Can you just give some examples so that, as we go along, we can, maybe relate it or our audience can relate it to their organizations.
Sure. So when we are talking about multi-agent collaboration, I often think of it as you'll have like an orchestrator agent. So the request goes to the orchestrator agent, and the orchestrator agent is like your brain. It decides where do I need to send this request to, and then the orchestrator agent will probably talk to a number of sub agents or domain specific specialized agents, whatever you want to call it, and then these specialized agents will do their work. They may even collaborate with each other, or they may send the results back to the orchestrator agent, and then the orchestrator agent would look through the results and decide if it needs to call another agent in the chain, or it needs to call two parallel agents. So that's where, so I call it as like that's one of the patterns, right? You have an orchestrator agent and you have different specialized agents. Another thing I want to call out is when you talk about multi-agent collaboration, there are different patterns that you can use. The pattern that I'll show today is basically agents as tools. So you have an orchestrator agent, and any agent for that matter. When you build, the agent needs access to tools, right? Just like our brain, when we need to analyze something, we access the environment around us, right? Like we have context, we have so many tools at our disposal. Maybe phone a friend is a tool. So think
Yeah.
about like when an agent needs to do a work, it needs access to tools. So in this case, the pattern that we'll be using is the other sub agents will also be considered as tools, and we are going to use the agent as tool pattern. The other is agents can also communicate with each other, just as HTTP requests. So in the agent core runtime, I could deploy multiple agents and they can call each other. But what I will show you today is actually agents as tools. So we'll have a Docker container, we'll have different agents which are deployed in that Docker container in the agent core runtime, and they'll communicate with each other using the agents as tool pattern.
Got it. Got it. Awesome. I'm gonna ask the same question to our audience as well. What kind of specialist agent would you build for your own case? We would love to hear them out. And as we are going through the rest of the show, we would love to hear if you have any questions in the between. Just feel free to post that in the chat, and we'll make sure to answer those as we go along. Awesome. Piyali, over to you. Like,
Yeah,
why don't you
sure.
share us something? Share us like how do we start with this, right? So
Yeah, are you able to see my screen or?
I'm just gonna add it right now. Yep.
Okay, awesome. So once you're able to see my screen, I'm just going to give a very brief run through of what we are going to be building today. Just let me know once you're able to see my screen, okay?
Hey Rina, thank you so much as you're building the KYC agent. Wow, would love to know more. We have Brittany. I have a news agent I love. Wow, all the tech news. Amazing.
Are you able to see my screen now?
Yeah,
Okay, awesome. So what I want to do is this is a GitHub gist, and Jigna will share this. Let's share this with the
yeah.
viewers as well.
We'll just post this into the comment section so that you can access the sample that we are referring right now.
And what we are going to be building today, so very quick, very high level architecture. I just have a UI that I have built, and this UI is actually through a Lambda. It's actually calling my multi agentic orchestrator agent and all the other agents that I have deployed on the AgentCore runtime. Right. So I'm going to go through this whole thing. So things will become clear as we progress through the show. So understand that I have a document processing orchestrator agent, and this orchestrator agent is actually calling a document summarization agent, a document comparison agent, and an enhanced deep analysis agent. And we'll go through what each of them does. When I show you the UI, it's going to become a lot more clear. And then what will happen is we are going to be deploying this agentic system on the Bedrock AgentCore runtime. And as a part of that, we are going to be seeing the observability concept that I just told you. We'll be looking through the AgentCore memory, it will go through that. And then finally, within the enhanced deep analysis agent, I'm actually using the AgentCore code interpreter tool. So we'll take a look at that as well. Now, to give you a feel of what this platform looks like, this is just our AI powered financial document analysis platform. And I'm going to do a live demo. I'll also go through the coding blocks so that you exactly understand how you can use AgentCore and deploy your own multi agent solution on AgentCore and make use of observability and all the good stuff that's there. So, this is my UI. What I'm going to be doing is I'm actually going to be uploading two financial documents over here, and they are basically two different kind of portfolios. One is a growth equity portfolio. I'll open it and I'll show you what the contents are. And then one is a conservative balanced portfolio. It's got a mix of different kind of funds. And what I would like to know is I want to do a comparative analysis, right, of both the funds. So what I'm going to be doing is I'm going to be calling a comparative analysis agent. Then I want an executive summary. So in my case, I have an executive summary specialized agent. And then finally, I'm also going to be showing enhanced deep analysis. This is where I was saying, right, it will actually go ahead and run some Python code in your code interpreter tool environment so that you can get a nice graph showing the comparison between the different two different portfolios that I'm going to be uploading over here. And then I have a comprehensive review, which is basically this is multi-agent. It'll call all the agents one after another and give you a comprehensive review of both the portfolios. So this is kind of a very, a 10,000 feet overview of the app that we are going to look through today to understand different concepts of AgentCore. Now, before I go into that, any further questions before I actually start going through, what are the steps now to be building this particular application?
Let me just go back to the comments. Nope. I think we are good to start.
Okay,
To our audience, feel free to post your questions. Just a quick reminder. I'll make sure to answer those or bring that into the screen as we go along.
awesome. So, the very first thing, as you are building this particular multi-agentic platform, the very first thing is, as I was saying, right? Most of the times we've already been building agentic apps, and you may say, like, I already have an agentic app. How do I deploy it on the AgentCore runtime? So, and you can use LangChain, LangGraph, any kind of agentic AI app that you have built. The very first thing that you would do is basically you would Dockerize that and you would deploy it into the AgentCore runtime. And going back to that, like I hope you all can see my screen big enough. So what I'm showing you over here is actually a Docker file that I have created. And you can see over here in this Docker file, the most important things, and the AWS documentation already says, like, in order to wire in observability into your agent that you're deploying on the AgentCore platform, what are the necessary environment variables that you need to have? So in my case, I have built this Docker file using these environment variables, right, for observability purposes. And then the next important thing is these are my agents that I'm deploying within my Docker container. And the names are actually, like, it kind of tells you I have an orchestrator agent, I have a comparative analysis agent, sub agent, or specialized agent. I have a document summarization agent. I have an enhanced deep analysis agent, right? And then I'm exposing them on port 8080. And the very last thing is this is important in order to be adding observability to the agents that you're deploying on the AgentCore platform. So this last statement is important. Again, all these things, we are going to provide you links. If you go through the links, the links will actually call out these same things that I just said. The only thing that you need to know is this is the Docker file. This is kind of the starting point if you want to deploy your own custom agents on the AgentCore platform. So that's kind of the first thing that you will do. The
Got it.
second thing. Yeah,
Piyali,
go
I'm so
ahead.
sorry. Do you mind just increasing the font little bit?
How about this?
I think it's much better than the previous one. Thank you, Rina, for pointing that out. There is one more question. I think it's from Devid. Is this service like an Entain?
I didn't quite catch it.
No, no, that's okay. I think the question was like how exactly the Bedrock Agent Core enables you to like deploy and operate highly capable AI agent security at scale. So it's like for infrastructure and how it would come to like real world deployment. But we got that addressed over the chat. So,
Okay,
anyways,
awesome.
thank you for asking that question.
So the very first thing that you'll be doing is basically you will be building this Docker file, and the gist, the GitHub gist that we are providing, we've actually given you a sample of this Docker file, so you can just replace it with your own agents and you can deploy it. Now the second thing, once you have a Docker file, it is actually this you will Docker file, the Docker image that you will be deploying on the AgentCore platform, and then the AgentCore platform will actually run this Docker container. So the next thing that you would be doing is actually you would be deploying this agent, right? So over here, and I'll go back to the gist because it's going to be easier to show that over here. So I'm going back to the GitHub gist that we are just sharing with you. This is the Docker file. And the second thing is building and deploying your Docker container. So that's what you will be doing. You'll be deploying this to AWS ECR repository. And once you do that, it's available over there. The first thing is you create your Docker container and you deploy it to ECR. The third thing is you're going to be creating an agent core runtime, right? Remember in the beginning when I was talking about the different features of agent core or functionalities of agent core that we will be going over today, we talked about agent core runtime. So this is the part of agent core which enables you to run your agents within the agent core environment. You have a custom agent, a Docker container inside which you've written the code for your orchestrator or your specialized agent. You can actually deploy that within the agent core runtime. And this is the way that you would be doing it. You'll use a Boto 3 SDK library, and the API is the create agent runtime. And if you see over here, I basically give the path to the ECR image that I just uploaded, right? And then once it's deployed, right, how are you going to invoke this? You might be having some UI code, you might be having a Lambda that you have deployed, and through that, you want to call these agents, you want to invoke the agent, right? So it's really simple. All you're going to be doing is you're going to be saying client.invoke agent runtime. This is the command that you use, and that's how your front end is now hooked to the agent that has been deployed in your agent core runtime. Any questions so far before I actually go into two important things that you need to follow if you are deploying custom agents in the agent core runtime environment?
Just looking at the questions. There are no open questions at the moment.
Okay, so two important things that you have to follow if you're deploying your custom agents. So, one important thing I already told you is you Dockerize it and you deploy it into the agent core runtime, right? That's a simple way of taking any custom agent that you have built. You can always Dockerize it and deploy it. However, there are two things. The entry point. So, if you are deploying your custom agent in the agent core runtime, what you need is an entry point, and there are two things, and a health check endpoint. So again, this is there in the documentations, but I'm going to call it out explicitly. If you have a custom agent, there are two things that you need. The first important thing is this slash invocations endpoint. This is the entry point. So when you call your agent in the agent core runtime, you're calling your document orchestrator agent. Slash invocations is the entry point. So you need that. And the second thing is actually a health check endpoint, right? Because it's a Docker container. So this is the ping endpoint. These are the two endpoints that you need. And that's it. If you have three things, the slash ping endpoint, the slash invocations endpoint, and you are able to build, you're able to Dockerize your agent, your own agent that you have built, you are ready to deploy it into the AgentCore environment. Those so three simple steps, and you can deploy it into the AgentCore runtime. Now, let's go over a little bit. Let's just spend 5 minutes going over, the design of the different agents that we have built for this document analysis platform, right? So this, where I am right now, is actually the orchestrator agent. And you will see, I was talking about a couple of things, right? So let's go back to this gist. I talked about AgentCore runtime. I also told you that when multiple agents, and this is irrespective of AgentCore, right? This is just if you're building a multi agent collaboration system where multiple agents are talking to each other, there needs to be context that is shared. Imagine that you're building a chat application, right? And I'll give you this example. Over here, I uploaded two documents, and we'll go through this live. But just to set the context, I uploaded two documents and I said, do a comparative analysis for me. It did the comparative analysis, and then I say, give me an executive summary. But when I say give me an executive summary, I am not specifying the name of the documents again. That means the application that we have built, it already knows what the past information was that was shared in this application on top, right? So I already shared the information about the two documents that I would like to analyze. It's not asking me again, give me the documents that you want to analyze. It's not asking that to me. The reason is that in AgentCore, I'm making use of the AgentCore memory. What I'm doing is, and I'll go through, the sections of the code in the gist, in the GitHub gist, which allude to this. But what I'm really doing is, in my orchestrator agent, whenever a request comes in, I actually create I create an entry in the AgentCore memory with this particular session ID. And when I'm returning the response back, I summarize that. At least for my use case, you can use different strategies, but for my use case, I summarize what I have done. And or you can also do multi-turn, right? So you can always actually just save the raw agent and user conversation as a JSON blob in the AgentCore memory. So what I'm doing in my use case is that I'm basically, whenever I'm returning a response back from my orchestrator agent, I am summarizing, or maybe I am just taking the last X number of turns and I'm saving it in the AgentCore memory. So the next time I ask a question in the orchestrator agent, what I do is I do a lookup. I go against the AgentCore memory and I pull the information. And from that context, I know the information that was shared with me earlier related to this specific session. So I'm not asking the user for redundant information that I should already be knowing. So that's kind of the beauty. It makes your life a lot easy. It makes coding a lot easy, because otherwise, just to think of the user experience, if the agent would forget, if you would build an agent without any memory, it would have to come back again and say, okay, what were the documents? And it'll ask this 10 times, like for every interaction, even in the same session, it will come back again and again and ask you for the information that you've already furnished. And these are some things, I call it as undifferentiated heavy lifting, that the AgentCore memory and observability already take care of for you. So going back to that same thing that I just told you about the AgentCore memory, what we do is the very first thing is, you could also go on the console and just create the AgentCore memory and associate that to your application, or you could use the SDK and create a memory, right? And I was telling you that there are two different kinds of memories, right? I'm just using a short term memory, you can also use a long term memory. And I think the long term memory also has different strategies associated with it. So I
A quick
create the.
question.
Mhm.
Sorry, Piyali. A quick question. Like, how do you decide, like which strategy is best for your application?
Yeah, so it's a little bit of, sometimes it's your use case which will really dictate. It's your user experience also, right? It's also what you want. Like, are you building an application where you just want to store everything about the user for the last whatever x number of days, then you're going to use one strategy. Sometimes it's like, okay, I'm just going to remember the interaction that the user has with my application for 60 minutes, then you're going to use a different strategy. Sometimes it's also the performance implications that it can have on your application. For example, when you save the memory in any kind of a memory store, you can summarize the conversation and store summarized transcripts or interactions, or you can store turn by turn conversation, right? Because you're sending something to the agent is sending something back to you, so it's kind of a JSON structure: request response, request response. You could take an entire request response for the last 10 turns and store it in the memory, and that's okay, right? But if you're storing 10, 20, 30, 40 conversations turn by turn without summarizing, it might affect the performance of your application. So what I would say is the performance implications, what are you really trying to solve for, rather your use case, and what is your user experience going to be like, what do you envision your user experience to be. These are some of the factors that you have to consider when you're coming up with a memory strategy. Does that help?
Yeah, yeah, that's good.
Awesome. So, as I was going back to that same vein, so we've created a memory, and then what I do in my orchestrator agent, this is where I was exactly saying, is a couple of things, right? First, I'm going to talk a little bit about the memory, and then I'll go back to the telemetry or the observability part of it. But essentially, what I do is in my orchestrator agent, you will see over here, I do a load conversation from memory. And you can go through the code later, but conceptually, I named it so that you exactly understand what I'm doing. I'm loading the conversation from the memory that is associated with my application. So there's always an ID that is associated, so it's only that particular application's data that will be stored in the memory. And again, I'm further delineating it with the session ID that I'm using, right? And further, there is something called as actor. In my case, I'm just using the orchestrator agent. For example, if you want to start storing every sub agent's information separately in the memory, then you can start having different actors for each. So actor is the person who's actually storing, right? Like, so in my case, it's the orchestrator agent's final response that I would want to store in the memory. So that's why I'm using the actor ID. But as I was telling you, right, it's per session that I'm using. And then turns, right? This is where I was telling you, you can decide the best strategy. In my case here, I'm using agent to user conversation. So every turn, like the last 10 turns or 15 turns, I'm really storing it in the memory. That's it. And then, so that was loading the conversation and then is storing the conversation. In my case specifically, when the orchestrator agent is synthesizing the final response and sending it back to the user, that's when I decide that I want to store the conversation in the memory, right? And as I was telling you, I am doing a turn by turn. I'm not summarizing in this case. I have used a couple of use cases where I'm actually storing a summarized conversation, but in this case, I'm storing a turn by turn conversation. That's pretty much it, right? And I build my orchestrator agent again. And in my case, my agent is a strands agent, right? So if you have worked with strands agent, you know how a strands agent is defined. And then finally, I was telling you agents as tools, right? So this is where all the other agents, sub agents, I annotate them as at the rate tools, and in turn, inside them, I define them as a strands agent, and basically, I just hook the tools to the orchestrator agent, and that's how these I'm using agents as tool pattern and at a very high level. But I have provided the code over here, and I was also telling you about at the rate post slash invocations, because that's really important. And the ping, right? Whenever you're creating your custom agents, you're deploying it on a Docker container so that it runs on the agent core runtime. You definitely want to take care of these things. One thing that I'm going to point out now, because this is all about memory, right? This is kind of the boilerplate code that you need for agent core memory. But one thing I'll talk about is the telemetry, right? If you want, like, I have just added some custom attributes, right? So this is how I basically add some trace attributes to the observability. And another thing that you can also do is when you define your agent, I'm going to go over here. You can always add trace attributes at the agent layer. So every agent in the observability graph, if I want it to be identified with a specific identifier, I can do that. If you don't want, you have to do only those environment variables in the Docker container is important. But I specifically wanted some specific or custom attributes for each of my agents. So each of the agents that I have defined, I have added some trace attributes over there. This is pretty much it, at least from a high level code perspective, before I start going in and I start showing you certain things, how we have built. And then I want to show you the observability graph on the Bedrock AgentCore runtime. And I also want to show you the code interpreter tool, that is the built-in tool. And if we have time, we'll also run a small test script against our tool and see how the charts are generated. So before I go into the demo, any questions?
No questions. Would love to see the demo.
Okay, awesome. So what I'll do over here, and I just kept another tab open because sometimes it just takes time. So I just wanted to have something up and running. So this is just the document analysis platform that I was talking about, and I'm going to make this a little bit big so that you know exactly the data. This is just some synthetic data that I have created, but as you can see, I have a
You might have to increase the font. So sorry.
okay. No, that's my bad. My bad. Can you all see this now?
Yeah, much better. Much better.
Okay, awesome. So there are
If you
two
can make
files.
it full screen, if you can make it full screen, that would be perfect. Awesome. Awesome. Thank you.
So we have two text files. Essentially, this is some two portfolios, right? I have a portfolio performance report of a balanced portfolio, and I have some data that I have written, right? I have a client, a strategy, there's some report date, there's some performance overview, asset allocation, and I'm just saying, okay, these are the kind of funds that I have in this particular portfolio. And similarly, and unless the persona that I have is a wealth management advisor, right? I'm responsible for taking care of my clients, and I build different portfolios to make them successful. I've taken example of two portfolios, and the second portfolio is a growth equity portfolio. Again, I'm going to make this big so that you can see. And
A quick question from the audience. We
mhm,
have Harshal asking a question. As you added open telemetry for the observations, so can we use any observability platform like Datadog or
you
Grafana or
can
anything of that
you
sort?
can you can use anything. You can just hook this up to any of your, like, the metrics will finally go to that particular observability platform. So you can totally do this because they all follow the open telemetry specifications, right? So as long as they follow the open telemetry specifications, you're fine.
Awesome. Thank you so much.
And so this is the second portfolio that I have. And again, I'm the persona that I am assuming is I am a wealth management advisor, and I have different portfolios, and I want to compare these portfolios. How are they doing? Right? The different funds in those portfolios. That's essentially what I'm trying to do. That said, what I'm going to be doing is I am going to be uploading those two documents over here, the documents that I just showed you. What happens is in the back end, nothing much. It's uploaded to an S3 bucket. Now what I do is, and actually even the uploading So I'm just uploading to an S3 bucket. And then what I do is I say comparative analysis, right? So I click on comparative analysis. This is going to take some time. While the comparative analysis is happening, let me just go ahead and explain to you, right? So what happens is I have written over here in my orchestrator agent that for comparative analysis, right, there is a specific agent that I want to use. So I have written via natural language prompts, right? I have prompted my orchestrator agent, which is my main agent, that for comparative analysis, go ahead and call another agent, which is the comparative analysis agent. And then what I do over here is basically I have written over here, as I was telling you, I'm using the agents as tool pattern. So I say call comparative analysis agent. And if you look over here, see, I have annotated this as a tool. And that particular thing, again, I have built a comparative analysis agent over here. I'm just using like different functions, but basically it's agent as a tool pattern. And I defined my comparative analysis also as an agent. I give it, it needs to do some task and I tell it what to do. One of the first things it needs to do is this agent actually has to go and download the data from the S3 file. So that's from the S3 bucket. So that's what I was saying. Unless until you bake in memory into your agentic platform, it will not know what's in the context. It will not know that the documents were already provided. So that's the beauty of AgentCore Memory, right? I have already hooked it into my orchestrator agent. I showed you like loading the document from the memory and even initializing the memory. All that is also there in this in my orchestrator agent. I showed that in the uh, little bit ago, right? I showed it in the gist. So that code is also over here, just easily mentioned in the gist. So now what will happen is the comparative analysis agent already knows what's in the memory. So it knows the files. And I just wanted to, so while we were discussing, the response has come back, right? And I also want to just show you, this is, I know this is maybe, I'm just trying to look at the logs real time. So if I and we'll go into the agent core console and I'll show you. But if you were to look at the CloudWatch logs of the orchestrator agent, I'm not even talking about the agent core observability, right? I'm just talking about the application logs of the orchestrator agent. If you were to look into it, you can actually see, all the comparative analysis processing has completed, and you can see that it is calling the comparative analysis agent. So I basically, this one another thing, best practice, please have enough of logging, right? When you're building a multi-agentic system, don't let logging be an afterthought. These are the things, if you think from day one, as you're building bigger, more autonomous systems, you just develop that muscle that, okay, as I'm building, observability has to be a thought right out of the box. Logging has to be a thought right out of the box. So as you're building it, don't let these be afterthoughts. These should be baked in right from the beginning. So this was the application logs that I'm showing you, right? I'm going to go back.
Piyali, just
Mhm.
one quick question from the audience. We have one question from the Itachi02. That's a very cool name, by the way. Um, I was using an open source observability tool, and when I deployed the agent locally using the agent core launch, I was not able to get the traces. I was able to get the traces, sorry, but when I deployed to the AWS Bedrock agent core, I was not getting the traces in the observability tool. By any chance, have you come across this? Any resolutions or anything of that sort?
I'll show you something. Um, Take care of this environment variable. Otherwise, sampling is done, and then sometimes when sampling is done, right, you don't get all the traces. So if you don't mind, if you have set this variable, let me know. If you have not set up this variable, did you follow all these steps? You must have. But this is one thing which caught me off guard. So I have mentioned this over here. Okay.
Awesome. And one more question from Harshil. If you can also just a quick glance of the front end code as well, like how that is interacting with this.
So the front end code is really lambdas, I'll show you. This is just a fast API lambda. So if you look at this, it's just a fast API lambda because async handling is easier, right? And streaming responses are easier with fast API. So that's it. This is just the front end lambda code. And the lambda code, I was telling you, right? This is exactly what I showed you in the gist client.invoke agent runtime. So going back to this gist, I think we had somewhere invoke agent runtime, right? And I have named it properly client to invoke agent core runtime. So see over here, invoke agent runtime. That's what you'll do in your Lambda code. So it's basically a Lambda code which is just calling. And both my front end and my backend, they are just lambdafied. I've just exposed the lambdas through an ALB. Okay.
Awesome.
So, going back to what I was saying, the orchestrator agent and don't let it be. So, I think the last thought that I had was don't let it be an afterthought, right? Logging and observability, you should think about it right at the get go. Now that we have got a response back from our comparative analysis sub agent or specialized agent, I want to show a couple of things, right? First of all, remember I was telling you, I don't have to tell it what my files are. And just, I know my output is verbose, but I did it on purpose because I wanted to prove the point that I'm using the agent core memory. I'm using this same session ID, right? And my request was this create executive sorry, this is the one. My request was compare the financial growth performance, right? But see what it's doing. It's actually retrieving from the memory available documents. And then it's appending, please download and analyze the relevant documents mentioned in my question. So it knows what your question is. And this is just the way I organized my prompt, right? In my prompt, I have actually written for the orchestrator agent, whenever a request comes in, first go to the memory, get the data, summarize it, and then append the original question to it. So that's the way I did it, right? And you would have to do something similar like this, and then it processes a request. And I'm being verbose on purpose because I just wanted to show the thought process. And then this is my actual output, right? It gives me everything between the two portfolios. Going back to AgentCore now, you saw that I had my Docker container set up with Hotel, that is open source telemetry. And you also saw that I had trace attributes and things like that, right? That I set up. What I'm going to be doing now is I just go to CloudWatch. And in CloudWatch, I have this. This is a new thing that you will see, application signals. So there is Gen AI observability. So I'll go in Gen AI observability, and let me just make this a little more big so that you can see, right? And you would have to explore a little bit because this is a new service, new feature. So I would highly recommend that you play around with this, right? And see what is helping you. What other things do you want to add? Like I was talking about the trace attributes. If you want to add something, because you can run all kinds of CloudWatch log insights and analytics on these logs, right? So if I go to Bedrock AgentCore, automatically the moment it's able to introspect your agent, the observability piece, you will start seeing your agent over here. So the agent that I am really interested in is my document analysis platform, right? This is the agent that I just deployed. Um, and I see it over here. And if I go over here now, I should be able to see the different sessions, right? And I've written over here. So this session was F2884, right? And you see this, the session ID, document
Yeah.
analysis, and ending in 884. So that means I know for sure like this is the right session. And if I go into that session, right, I should be able to see a trace ID associated with the one request, right, that I sent. And here, if on this trace ID, if I go, I want to show you two things. One is a timeline. This is where I was saying, right? For a request, trace is again connected to spans. Spans means that particular request could go through multiple apps, multiple agents. So each of them would then show up as a span. Each of the functions inside the agent will show up as a span, right? So you'll have to kind of, if you remember, I did have a S3 get object. I was telling you when the very first thing that the comparative analysis agent has to do is it needs to download the files from the S3 bucket. So I can see that it did the S3 get object operation over there to get it, to download it from the S3 bucket, right? And you can see the entire call chain over here. But what I really like is this trajectory. And let's see. So if you blow this up, right, you can actually see the entire call chain, right? And then you could click on one of them and then you'll have to like scroll down, and you'll be able to see like that for that particular call chain, what happened, what events were called. So I really find this view, like I really love this view of the trajectory. And then you can click on these and then you can go down further. Over here in the lower section you can actually see the entire span trace over there. So what I would say is, at least build a small agent, put some observability, put some tools in it. It doesn't even need to be like, you're hooking specialized sub agents with an agent. You can just put a number of tools, right? For example, downloading a file from S3 bucket could be a tool. Sending a summary could be a tool. Generating a summary, sorry, can be a tool. So many things, right? Or creating a chart can be another tool. So create a simple agent, have different kind of tools, add observability, make sure it has got logging, and then deploy it and see how it looks. That would be the easiest way to start learning um, traces and spans, and then how these graphs show up and how you can find the performance bottlenecks, right? So start with something small, and that way you will understand exactly what are those different features that you would like to use, right? Slowly you will get the entire picture. But I really like this trajectory part of the view. So that was a little bit into the trajectory piece of this, right? Just a quick time check. How much time do we have?
I guess we just have 5 minutes more. If
Oh, we
you
just
wanna
have five
show,
minutes. I'm
yeah, if
just
you
going
wanna,
to click on enhance deep analysis.
okay.
Let this run in the backend. The reason I wanted to show this to you is because this enhanced deep analysis is actually making use of an agent core tool called as the code interpreter tool. So inside that, I'm actually sending a Python code to generate the graphs to a code interpreter tool in my enhanced agent. And this code interpreter tool is like, you don't have to manage the code. It will start a container on its own, and it will run your code, it will generate, and my code interpreter tool is actually then uploading the chart that it generates back to the S3 bucket. So that does take a little bit of time. If we have time, like before 5 minutes, if it completes, like because it does a lot of analysis, I'll show that specific one to you. But however, what I did is, for our conversation purpose, right? So this is one of the previous runs that I had. Always, the way I'm storing it is I'm storing it in the charts folder with the session ID. So if this completes, we will have another one with that session ID. But this is what is generated, right? So this is something very similar that I did. And I'm just going to show you at the end when the code interpreter tool runs. This is the chart that it actually generates for me. So you can see a performance comparison between the growth equity and the conservative balanced portfolios. It shows the returns, the income comparison, the risk return profile. So I have a custom Python code that I'm asking the code interpreter agent to run, and I have provided that to you in the gist, right? So if you want to try it on your own, there is going to be a section over here called as test code interpreter.py. You can actually take this Python code and run it in a code interpreter environment. And what you can actually do is, if you go into this is running right now, so if you go over here, right, it will show you that this interpreter session is actually ready, it's running, and then after some time it will die. But while it is ready, there is an example code in the sandbox kind of a code which is provided. You can write a Python script, you can actually send this code, right? In your case, your argument is going to be code like this. Instead of this hello world, you can actually give that entire Python script that I just showed you and run it and see if it outputs the png file, right? That will be really cool. So what I would say is try to do at least that much, and you don't need the whole code, right? You just have that Python code, create a code interpreter tool over here, and just create a test script, Python test script, and just run that code instead of the hello world, and you'll see that png file being generated. So I will take a pause because I know we didn't have much time, but we did cover observability, we did cover custom agents, we did cover multi-agent collaboration using agents as a tool pattern. The agents can also be different runtimes, right? And they can talk to each other via HTTP. And then we also took a look at the AgentCore code interpreter tool. So AgentCore, there are a lot of other things, but at least, we looked at 4 features of AgentCore today. I'll
Awesome.
take a pause now.
Yeah, I'm just gonna remove the screen share for now and just have both
Awesome.
of us as we are just wrapping up. A quick question from the audience. Yeah, we'll share the gist on the YouTube as well. And the sample code that we just showcased is present in the gist, so you can obviously take a reference of that. um yeah. I guess just to wrap up, right, any last tips for our audience who are just starting with the journey, or they are at least progressing with some of the concepts here? Like, I know you did mention that you should talk about observability and not take it as a separate thing, but as we progress and into building this, any other tips that you would like to
Yeah.
share to our audience?
So I think specifically around multi-agent collaboration, what I'll say is start with a single agent always. It is a very organic choice. When you start small, as you're building, you will start seeing that in a single agent, only so much of memory is there. If your prompts become too big, if it's trying to do too much, you'll start seeing that the responses are not as great. So it's almost like an organically you will start seeing, oh, it's like a light bulb moment. You'll see, like, oh, now I do need to split this into specialized agents. My agent is becoming too big. My code is becoming too unwieldy. You'll start seeing those signals. It's just the same software engineering principles that we have followed all along, right? It's an organic switch. So I would always say, don't intentionally think that I have to build a multi agent collaboration system. Intentionally think, let me start small, and I will know when I need to split it up into specialized agents. um,
Yep.
that would be the best way to go. And logging observability always, like, please take care of it right at the get go, don't let it be an afterthought.
That's an amazing tip. Thank you so much. And I think that's a perfect way to end this. So thank you so much,
Thank you.
for sharing some of the amazing work that you have done, and, educating us, like, how can we, use this technology. To our audience, I hope you learn something new. And if you have any questions, feel free to reach out to us. You can, reach out to us on LinkedIn as well. Stay tuned to our next episode, same time next week. We have a lot of exciting stuff coming up. We are going to also have reInvent conference coming up, so would love to show you a quick preview of what sessions that are we're going to have this year. So it's going to be really cool. So with that, I would like to say thank you one more time. To our audience, we'll see you next week. Thank you so much.
Thank you, Jigna. It's always so much fun to be here with you.
Yeah,
Thank you.
thank you.